Hello, Chem students. In this video, we're going to talk about what so many people are interested in, calories, right? So diet is huge and everyone's concerned about that as well they should be. And we're going to relate this to the energy that we discussed in chemistry. And we're also going to use it in helping us understand calculations and the different units of energy. If you watch those earlier videos, we talked about the unit of joules for energy that we derived. A lot of times we hear calories. So I have this picture of just a cracker box. And one of the things I want you to notice is you see right here the unit of calories. We also see the unit of kilojoules. So a kilojoule is just 1,000 joules, right? And then at the very bottom, really what's important in nutrition is what I also want to show you way down here at the bottom is, and this is really what you should be concerned with when you're consuming food, is where the calories are coming from, is calories per gram of fat, carbohydrates, and proteins. Those are the three macromolecules that we're concerned about in nutrition, right? There's also nucleic acids. We're not so concerned about that from the energy that comes from our diet. It is a macromolecule, but those three macromolecules, fat, carbohydrates, and protein. And what I want you to notice is fat has 9 calories per gram, okay? As opposed to carbohydrates and protein, which is only 4. And we'll apply that in some word problems, but I just want you to notice that there is more calories per gram of fat than the other two. And that has to do with the amount of cycles that it undergoes through beta oxidation and then through the Krebs cycle and the electron transport chain. That's kind of a later class, it's a different class, but that's basically why there's more calorie content per gram of fat. You can think of it as there's more condensed number of carbons in fat. So how do we measure calories? Well, we use a calorimeter. So what is a calorimeter? So typically with a calorimeter, we are measuring heat transfer. And we've talked about how heat goes from hot to cold. So I can take a food source, right, inside a chamber, and it can burn, combust. And as it burns, it's releasing heat, right? So where's the heat going to go? The heat's going to go from hot to cold. So what happens is the food, as it heats up and releases this energy, the water that's in the chamber around the combustion chamber absorbs this heat. And when it absorbs the heat energy, now the water molecules are moving faster, there's more heat. And how are we going to measure that transfer of heat or that absorption of heat? We're going to use a thermometer. So this is essentially how we measure how much heat is or how many calories are in a food. We have the food, which I'll call the system, right? Releasing energy to the surroundings. Okay, so the water is the surroundings. So as the heat's being released from the food, the water is absorbing. So equal in magnitude, the energy, opposite in direction. The system releases it, the water absorbs it. How do we measure the absorption? Well, we take a temperature reading. Now, why is that important? If I have 1 gram of water and I want it to go from, let's say, 25 degrees Celsius to 26 degrees Celsius, that requires energy. Now, earlier we said we measure energy in the form of joules. So 1 gram of water to go up 1 degree Celsius requires 4.184 joules. Okay, so that 4.184 joules is how much heat energy must be absorbed by the water to raise it 1 degree Celsius. Well, because we use a calorimeter, we like to change the name, and we end up changing the name to calories. Okay, but I'll keep going. So the heat is lost by the sample. So the system, the food sample, the heat is lost. So heat and this is interesting to write, is written as Q. And I'm going to say this is the system, right? Or the food. So let's do food. The system is the food, and heat is lost. Anytime, and the reason why the heat is lost, it's again, it's releasing the energy. Anytime you lose something, that's bad, right? So I'm going to say it's a negative value. When I lose heat, that's negative, right? If you lose money, isn't that a negative thing? You don't want to lose money. So heat is going to have a negative value when it's lost. This is also referred to as an exothermic process. Exothermic is a negative value. Now, on the flip side, right, the water, which is the surroundings, it gains the energy. It gains the heat. Anytime you gain something, isn't that a good thing? Like if you gained a bunch of money, isn't that a positive thing? It would be for me. I'm struggling here, but yeah, so gain. If I gain heat, right? If I gain heat, that's a positive value, and that's called endothermic. Okay? So an exothermic process is where heat is lost, and that's negative. A way of you can use to help you understand is the prefix ex. When you exit, what do? You leave a room. So exothermic is heat leaving. When heat leaves, it's negative. Why? You're losing it. Anytime you lose something, it's negative. Endothermic. Well, look at the prefix en. I'm entering, right? Anytime something is entering, so what does that mean? Endothermic, heat is entering, that's positive. If I gain heat, that's a positive value. If I gain money, that's positive, man. It's awesome. So how is this related to food labels, right? And nutrition? Well, again, I told you that 1 gram of water, right, to go up 1 degree Celsius, right, just 1 degree Celsius, so like 25 to 26 degrees Celsius, requires 4.184 joules. Why not make an easy standard reference point? Why not make it 1 cal, right? Then our life's a lot easier. So that's the term cal. But it's confusing. Why? Ay, ay, ay. The dietic calorie, don't ask me why they did this either, but they did. The dietic calorie is not little c, it's big C. And the dietic calorie, the big C, is really 1,000 little calories, what we study in chemistry. I don't know why they did it. You know, don't a lot of people get angry at me. It's not my fault. I think what they did was they didn't want people to freak out when they flipped over a Snickers bar and it said 265,000 calories. It's much easier to flip that Snickers over and for it to say 265 dietic big cows. So now you don't feel so guilty when you're hungry and you eat that Snickers. So I want to emphasize dietic calorie is really 1,000 little calories, and that's what we use basically in chem. You can think of the big cal as a kilocal, and when you go back to that first slide, that's really what they were talking about. So food types, right? We talked about joules, and there's kilojoules, but really the kilocal per gram, which is the kilocal, right? The 1,000 calories, the little cal is 1 dietic calorie. So if you go back to that first slide, there's 1 calorie per gram. They really mean 1 kilocal or 1 dietic calorie. And which one was the highest? The fat. There's 9 calories per gram. Now, why is this useful? Well, now we can count calories, right? If I drink a cup of milk and it has 12 grams of carbohydrates, 9 grams of fat, 9 grams of protein, I can figure out how many dietic calories or kilocalories in that 1 cup of milk? How do I do that? Okay, 12 grams of carbohydrate, where there's 4 kilocalories per gram, 9 grams of fat. This is the one that's got more calories, 9. 5 grams of protein, 4. Easy. These two are 4, this is 9. I tally it up. This has 2 sig figs. It's multiplication. So this number is 2 sig figs. So because it ends in a 0, what do I have to do? I have to put a decimal. So that trailing 0 counts as a significant figure, and I have 2 sig figs right there. Thank you, decimal. Now, this has 2 sig figs, and I'm getting these numbers from the problems, right? I'm not making these up. This is the problem in the book. So 2 sig figs times 9, I treat it as an exact number because it's a conversion factor. I get 2 sig figs here. 2 sig figs, 2 sig figs. Now, this is what tricks people up. These were the multiplication rules, so I picked the fewest sig figs. When I add everything up, I'm going to the precision, which I like to say the placement value. And the placement value here is the tenths. So now I have to follow those rules. So my final answer goes to the tenths, and it confuses people because we've had 2 sig figs, but if you look, this is 3 sig figs now. Why? Because I have to follow a new rule for addition and subtraction, and I use what's called precision or placement value. So calories in food. What are some good sources of fat? Beef, very high fat content, right? Steak. Who doesn't like a rare steak, right? Well, I'm sorry. Many of you may not, so I apologize. Sorry about that. But anyways, I always like to show students, really what you're looking at, if you really want to look at diet, is how many grams of fat, because that's going to contribute to a high caloric intake. And it's harder to burn the fat. So I always say input output. You want to lose weight, you got to take in less than you use, right? So if you want to lose weight, you got to burn more calories than you consume. If you want to gain weight, well, you got to take in more calories. So input output. So what's some physical activity that really burns a lot of calories? Definitely not sleeping. Definitely not sitting, which unfortunately I'm doing a lot of right now. But what are great things? Swimming, running. They should have jump rope. Jumping rope is a great form of exercise. It burns a lot of calories. But that's pretty much this video. I hope you enjoy the concept of calories and how it was derived from a calorimeter, and the concept of input output and systems and surroundings where the heat can be transferred from the food source to you. And how do we measure that calorie intake? We use the calorimeter and water as the surroundings. So thanks so much for watching. I know this was a long video, but I appreciate your patience.